Now we are going to see about the next topic. In the last class, we have seen the description of data using attributes. Now we'll see how we can represent the data not only from the attributes, from certain statistical properties. So we are going to see two things in this section. One is known as measure of central tendency. What is the uh, midpoint or what is the mean point of the data? Where the data is centralized. So in the measures of this, and secondly, we are going to see dispersion of data, how the data is scattered in the given space. We're going to look at three different aspects of measure of central tendency. Firstly, we'll see what is mean. These things already you know, but I'm just revising it in perspective of data science or data set. Mean and then median, and the third one, mode. These three values will give us a snapshot of the data. If you know the mean of data, you can have an understanding of data. For example, I want the mean of all your marks. So then what I will understand? I will understand when I know the mean, I understand what is the average of your class. So mean, another word is average. Average. And how do we calculate average? If we have a set of values, set of xi, then the mean is calculated as the number of values 1 by n into sigma I is equal to 1 to n xi. Sum of the values by the number. Sum of the values by the number of the values or the attribute. So, for example, your marks in the mid examinations or out of 40, one subject you got 30, another subject you got 32, another subject you got 38, another you got 28, and another you got 35. Then what is the average? So, totally 5 subjects are there, 30 plus 32, 62, 62, 98, 62, 92, 100, 128, 128, 30, 158, 163 by 5 is your average. So how did we calculate? The sum of all these numbers, 32 plus 38 plus 28 plus 35. There are 5 subjects, so it is 5. So this is your mean. So mean tells us what is the value of that data set. So if I know the mean, I can comprehend what are the values, because all the values will be surrounded, will be dispersed around the mean. And sometimes each value will have some weightage, and then we call that mean when we take the weightage also into account, just like frequency, we call such type of mean as weighted mean. In that case, we calculate by sigma xi wi, where I is from 1 to n, xi value multiplied by its weight wi by sigma wi, the mean of that. So what we have seen, mean. But the problem with mean is mean will give you the overall indication of what the data is, but mean is very sensitive to outliers, anomalies, or sometimes the data may contain certain outliers or anomalies, which, for example, somewhere by typing mistake, I instead of 135, I typed 135. Then your mean will change very rapidly. And in that situation, the mean may not represent the data correctly. So sometimes people will also prefer trimmed mean. Trimmed mean is a mean where you eliminate the lower and upper values and you calculate the mean so that you will have the picture of the maximum data even if there are outliers. The second measure of central tendency is median. So what is median? Median is the central value. For example, if you arrange the data in ascending order, 28 marks, take the same example, 30, 32, 35, and 38. So the middle value is known as median. If the given data set has odd number, n is there, n is the number of elements. If n is odd, we can get this median immediately. Because it is odd, we can remove the even number this side, even number that side, and I can find the center with n plus 1 by 2 very simply. But when there is even number, suppose you have an even number, n is even, then we cannot get a single center. What we do is we take average of middle two values. That is the median. For example, you have a data set like this 10, 20, 30, 40, 50, and 60. And here we have 6 numbers, so there is no single mean, single median. So we'll take the middle two and n plus 1, and we take the average of that, 35 will be the median. So median will give you what is the central value, how the data is distributed. And the third one, that measure of central tendency that we are going to see is mode. Mode. Mode is most repeated value. Sometimes we may have a number more than one time or two times or three times, then that most repeated value is mode. In this given set, there is no mode because no number is repeated. Even in the top number, here also there is no mode because there is not a repeated value. So there is no mode. But you can have one repeated value, then you can take that as a mode value. So three values, three properties, statistical properties to describe the data: mean, median, and mode. The three things that we have seen. In this junction, let us also see a normal distribution. Normal distribution, which is very important in statistics, not only in statistics, but also in the machine learning and data science. Normal distribution, which is also called Gaussian distribution. Gaussian distribution. So Generally, all the natural distributions, for example, height of the people. So this type of distributions are a bell-shaped curve. You can see here in the diagram, bell-shaped curve. That means most data will be near the mean, near the mean. That is bell-shaped curve. And uh, in case of normal distribution, if it is standard normal distribution, there is no skew. That means there is no, it is a symmetric distribution. Then remember that when it is symmetric normal distribution, mean, median, mode, all will be the same. All are equal for standard normal distribution without any skew. But sometimes it may not be the case. You may have more values towards not at the mean, but more at the uh, other side. Then we say that it is negatively skewed data. In that situation, mean is less than median, less than mode. Mean is less than median and it is less than mode. This is negatively skewed. Skew means distortion. Then on the other side, we have a positively skewed data where mean is greater than the median and in turn it is greater than the mode. Then that type of data is known as positively skewed data. Then going further, we'll talk about dispersion of data. Dispersion of data. How the data is dispersed or distributed. So firstly, we'll see about range. Range is very simple. The minimum value and the maximum value. When you specify these two, this is range and we can calculate that value by max minus minimum. So range will tell you what is the maximum value and what is the minimum value. If you specify those two, it is known as range. Then secondly, we talk about another division of the data as quantiles. Quantiles. For example, given 10 numbers, if I divide them into half and half, and if I find the central value, then I call it as median, right? Median. And in the median, if I take another half value, that is known as quartile 1. And to this side, this is quartile 3. And median can be called as quartile 2. That means if I take 25% of data, that is Q1, 50% of data Q2, and 75% of data Q3. This is quantile. Quantile is a general term. You can divide the data into different parts. If you divide the data into 4 parts, then it is called quartiles. Q is equal to 4 quartiles. If you divide the data into 10, then they are called decile. If you divide the data into 100 parts, then it is known as percentile. Percentile. So why we need such type of distribution? We know the rank, right? We know rank, you know percentage,
how the percentile is different from percentage. Percentage will tell you your marks, your how much you got out of total. That means 75 you got out of 100.
Rank will tell you, for example, your rank is 3200 in MSET, then it will tell you that
Before you, there are 3,100, 3,199 people. But I don't know about how many are behind you. That I cannot tell by seeing at the rank. But percentile will tell you how many people are before you, ahead of you, how many people are behind you. For example, if I say 98 percentile, that means 98% of the people are behind you and 2% people are ahead of you. So it will tell me what is your exact position. So quantiles is dividing the data into different equal parts.
equal parts. If we divide the data into 4 equal parts, then it is called quartile. If you divide the data into 10 equal parts, then it is called decile. Then if you divide the data into 100 equal parts, then it is called decile. Then third measurement for the dispersion of data is known as IQR, interquartile range. Interquartile. This is already we have divided the data into 4 parts, and if you assume that Q2, Q3, this is 0, this is 25% part, this is 50% part, this is 75% part, this is 100% part. Then interquartile ranges, you will eliminate the lower bottom, you will eliminate the upper bottom, and you will consider only this 50%. So interquartile range is Q3 minus Q1, because there is always a likely situation where you will have anomalies in this extreme or in this extreme. Here also we have seen most of the data is around this one. So these may be extremes. So we don't want to focus our attention on these extremes. Rather than that, I want to analyze only the middle 50% data. That is known as interquartile range. Let me show you that. So this is quantile where you have divided into 25%, 70%, and this is your median, and we can calculate them. Percentile is dividing that into 100 parts and locating its position so that who are behind you and who are ahead of you. So suppose some person got 90 percentile. That means, and he got 94 marks. That means 90% students are below him and 10% students are above him. So if you say 30 percentile, then you are taller than 30. If it is a height, 30% and shorter than the 70%. So interquartile range is Q3 minus Q1. So with this, we can also represent data by a 5-number summary. 5-number summary. If you want to represent the data, 5-number summary will easily very helpful to describe the data. These 5 numbers are number 1 Q1, number 2 Q2, and number 3 Q3, and minimum and maximum. Minimum Q1, Q2, that is median, Q3 maximum. If you specify these 5 values, we say that it is 5-number summary. By the 5-number summary, we can draw a box plot. Let me show that box plot to you. So this is an example of box plot. What you do in this box plot is this central line is the median Q2. This is Q1. This is Q1. This is Q2. That is the median. This is Q3. And this is your min. And this is your max. So when you plot these values, these five values for different distribution, you can see which one is varying. What is the median? This has more median, this has less, and this has in between. You can compare and you can have a clear-cut picture of the data sets. This is known as box plot. Box plot is made from five number summary. What are those five numbers? Min, Q1, Q2, Q3, and max. And this line, if this line is exactly at the center, that means the data set is balanced. There is no skew in the data. But is if your median is below that mean, then there is some skew of the data. We can also use another graphics like histogram, quantile plot to understand the data sets.